Hello to everyone. I'm Martin from FIQUS. It's a cooperative software uh, development from Argentina. I've been working, as Rao said, in a feature for the chat in order to replicate communications between anything that is connected to the chain. So I'll first show kind of a white box uh, demo, and then the black box. No, sorry, black box and then white box. As you can see, I have two instances of the Zulip chat. This is, I would say, the main, and this is the second one. So I'll just send a message. Like, just send the message. I have something running here. The chain replica is the one that upload the message to the blockchain. It doesn't really matter now how to understand how it does it, but the important part is that it will do it. We need to wait success. So suppose that you set up a new instance and you run this script that I made in order to get the messages, the new messages, right? Or the one that are on chain. They have, you see that it added one of four, but it's not four. I also connected to a Tomislav instance of Zulip. So now you'll see here that the messages are here, or well, the message I sent, right, is here, and Tomislav also should have that. We can check that. If you don't mind, I will show some developer things, I would say. This is the database. This one is from the first instance. Then I have the second instance, as you can see, Postgres 2. And finally, the one from Tomislav. So there's a new message here in the first one. In the second one. And finally, in the one from Tomislav. The same message is replicated in every instance connected to the chain. And if you, Tomislav, have also your instance, or it doesn't really matter that?
Yeah, I can show you later. But yeah, I see the message.
Okay, nice. I trust you. So yeah, if I can show you the other part of this, the script just get the, using Roland, we get the tables, the keys, and all of that, and the records, of course, and all of that is parsed in order to replicate those messages. Actually, are not only the messages, because as we can see, also the record in the user message table. The message has a bit more information related, as we can see here in the diagram. Oh, I'm better to do it here. So the message, what we are copying now is the message and the user message. But there are a lot of other tables and information that should be copied. So this is just the tip of the iceberg, I would say, in order to replicate information properly. So this is actually, Tomislav also updated this raw part to JSON in order to parse all the information. So this code should be 3 lines, I would say, to parse the data, get it from the chain. So basically, that's what the script does. I don't know if you've had any question or I went too quick and you need me to clarify anything.
Yeah, I mean, this is super exciting. We really appreciate it. I do have one question. So actual work days as opposed to communication and coordination days, actual work days, how long did it take you to do this?
Code?
Yeah.
4 days. And I've never code in Roland, to be honest.
Yes, that's what I like to hear.
It wasn't really, well, I work in the IT industry. So I've been working in this industry for 15 years, I guess. So if you're a senior developer, it shouldn't take too long to understand how to do this. And if you're a blockchain developer, oh, easier. I can do almost everything. So it's a different paradigm, but it's not that hard.
And that's what I like to hear. We were recently talking with some folks who felt that the adoption curve was going to be very steep, and we love to see the data points like this which prove that wrong. Thank you so much. I really appreciate that you taking the time to demo, and we're looking forward to doing a lot more work with our sister co-op FIQUS. This is awesome.
Thank you. Thank you very much to answer our email and of course having some chats and calls and giving us the opportunity to work together.
Great. Looking forward to doing more. Sure. So Tomislav, you have a demo.
Yes, I can share my screen. So what I want to show is like a continuation of what we've seen with Archet. So how we are pushing messages to the chain. In Archet, or in Archet example, this is done directly. We are listening in Node.js, we are listening for Postgres to receive the changes, and this console application creates a deploy and push to the chain. In a more in some like a production environment, we want to have some kind of queue in between. So I created this simple example which uses RabbitMQ as something that stands between the data and the chain. And instead of controlling this with commands in the console, this functionality is exposed via HTTP API. And I'm using this one library, which is very nice because already provides some debug environment and very easily definable HTTP endpoints. I only placed some basic information. I didn't file how to start, so you can play it, but play with it. But there is no like very deep description of everything. But whoever wants to fill it, I think it should be enough. So let me first start the server, which also provides some additional information, what controllers are started and what APIs are available. So with that, I can open this API inspector page. This is provided by this DeepKit framework. I have three controllers specifically for Arnode and RabbitMQ, but the main is this Hydra controller, and I'm calling this hydration as something that is importing data to the chain. And so what I want to show is these two main methods. The first is initialization, because first we need to set up RabbitMQ, listen for the messages, and set up the producer to accept our messages via API. So I just want to show that this way of thinking can be very nice for any developers to, without knowing any deeper understanding how to set up Archer network, he can use the HTTP API, which is much easier. So now that this is started, I will try to initialize again. Okay, I get the ready command, ready response. So now I also want to show the logs from RabbitMQ and Arnold. So now when I send some message, and this is just a very simple rolling that it will only accept whatever data I have sent to response the same data back. But this is not what I want to show. I want to show that I can send multiple messages, and this will be packaged up. RabbitMQ will receive it, and it will not block the sender. And when block is created, in the time when block creation is in progress, we can still send more messages that will be packaged up in the next block. So I will just push some of the data to the RabbitMQ. So now we are seeing that the block is starting to be created. I will push a little more messages and even more. And I have a very simple code that will just see if new messages are still waiting, and it will create another block. And when all messages are processed from the RabbitMQ, it will stop. And this is it. We can see here in the log, queue is processed all the messages. And this is all that I want to show. If you have any questions.
This is really cool. Thank you. How long did it take you to put this together?
Oh, this is in 2 days, so like 10 hours. And definitely this DeepKit framework helped me a lot. I mean, there is some learning curve to understand it, but of course, this is exactly why I was choosing this framework, because I want to modify the Archet so that it's also much easier to use.
Understood. This is cool. Now, I think we talked about how in the long run, so this is a quick and dirty integration with Rabbit, but in the long run, it would be nice to have a deeper integration with Rabbit so that the so you could have a Rabbit queue behind a channel, and so then you can do a for comprehension syntax to get data directly from the channel, and you can do an output syntax to put directly data on the channel from Rolang. Yeah, which I think would be lovely. And in fact, we would like to do that for all of the different, transport mechanisms, right? SMTP, etc.
And I'm planning to show something very similar, because I already have this demo for HTTP, and instead of connecting directly to RabbitMQ, specifically for RabbitMQ, I'm thinking to show example where from Rolang we can directly connect to this standard output and standard input, which can enable us to connect to whatever we want, RabbitMQ via some additional code. But it will be very nice to show as a demo.
Yeah. This is awesome. Unfortunately, we have so much material to get through today. We have to move on to the next thing, but this is really quite exciting and goes towards what we've been saying, which is that in order to make this kind of experience of high availability, high responsiveness at the edges of our chain, something like Rabbit is a perfect buffer, right? So you can have external applications, enterprise applications, which are talking to Rabbit, in order to get stuff into chain, and they could just dump, bulk dump into Rabbit, and then Rabbit says, "Yep, got it all," and then puts it on chain at its leisure. So, which is standard enterprise design pattern. Thank you very much. This is great.